Hello children, let us continue with chapter number 9, some applications of trigonometry of standard 10th. Here in this video we will be dealing with question number 3 to 5 of the exercise. Now question number 3 is, a contractor plans to install 2 slides for the children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter and is inclined at an angle of 30 degree to the ground. So the angle here is 30 degree for the slide which is made for children below the age of 5 years. And the height here is given to be 1.5 meter. Whereas for elder children, she wants to have a steep slide at a height of 3 meters and inclined at an angle of 60 degree. In this, the angle is 60 degree and the height is 3 meters. What should be the length of the slide in each case? We are going to diagrammatically represent this slide. Both the slides are shown and well-labeled diagram is made. ABC is the figure that is used for the smaller children and PQR for the elder ones. Now in this case, we have to find out the length of the slide. That means I have to find out AB and PQ. Let us explain what AC, AB, PR and PQ is. AC is the height of the shortest slide, which is 1.5 meter, and AB is the length of the shortest slide. Now we are going to consider triangle ABC, which is a right angle triangle. Now AC is the side which is known to us, the length is 1.5, and we are told to find out the length AB. If I think of angle 30 and I use the sine 30, sine value of 30 degrees, then it is AC upon AB. Here sine 30 is a constant. I know the value. AC is also known to me. The only unknown is AB. So when I solve it, I directly get the value of AB, which is 3 meter in this case. Next, the similar thing can be done in the another triangle. PR is the height and PQ is the length of the slide. Again, in this right angle triangle, I am going to use sine 60 because PR is one known side and PQ is the one I have to find. Here, again, I have only one unknown because sine 60 is a constant value. PR is also given. So when I solve, I directly get the value of PQ. Now PQ is 6 upon root 3. Here we are going to rationalize the denominator and I get PQ as 2 root 3 meters. Now that's question number 4. The angle of elevation of the top of a tower from a point on the ground is 30 meter, which is 30 meter away from the foot of the tower is 30 degree. Now there is a tower and there is a point on the ground which is 30 meter away from the tower and the angle of elevation is given to be 30 degree. Find the height of the tower. The distance is given, the distance of the point and the tower is given and the angle is also given. We are supposed to find out the height. Let us diagrammatically represent it. And the diagram always should be properly labeled. Now, let us give the reference. AC is the height of the tower and BC is the distance of the foot of the tower from the point where we are standing. ABC is obviously a right angle triangle because height and the horizontal, that is always perpendicular. Here I am going to use the tan value. Now why am I using the tan value? Because here BC is the length that I already know and AC is the length I have to find. These two sides come up in the ratio tan 30. The tan 30 is a constant, that is 1 by root 3. AC is the unknown, that is the aim. I want to find that length, and BC is 30 meter. So let us solve it by cross multiplication, and I get the AC as 10 root 3 after rationalizing the denominator. This is how I've got the height of the tower. One more example. A kite is flying at a height of 60 meter above the ground. That's the perpendicular height. The string attached to the kite is temporarily tied to a point on the ground. So, the string is always slant. The string which is attached to the kite, it is always slant and it is attached somewhere at a point on the ground. The inclination of the string with the ground is 60 degree. That angle between the horizontal and the string is 60 degrees. And the height of the tower is also given to be 60 meter. Find the length of the string, assuming that there is no slack in the string. I have to find out the length of the entire string, but I have to consider that it is straight. So let us draw the triangle which is formed here and label it. Once this is done, I am going to put the reference over there. AB is the height of the kite and AC is the length of the string. We have been told to consider AC as a straight one. Now it becomes a right angle triangle ABC. So in this right angle triangle ABC, I know the length AB and my aim is to find the length AC. So the relation would be sine, which is opposite upon hypotenuse. So here when I use sine 60, that's a constant value. AB is given to be 60 degrees and AC is what I want to find out. So here AC comes out to be 40 root 3 meters after rationalizing the denominator. And that itself is the length of the string. That's all in this video. There are many questions to come up in the coming videos. Thank you.